Right, so a fairground operator wishes to build a marquee in the shape of a cuboid, so they're just trying to build a tent. So here's the marquee they're trying to build. You can imagine it looks like that. Okay, it's just got 1, 2 walls and a third roof. Hasn't got the floor, hasn't got the sides. Okay, so they've got how much canvas do they have to make that? 1,000. Okay. So in other words, if I was to unfold that, what I would have is just a piece of canvas, with 1, 3, and 2. Can you see how that goes into that? Yep. And so what is this area? Okay. Now does that help you guys, or some of you guys, enough to have a crack at that? Yep. Or you got more?
No, that's good.
Okay, pause this. Okay, after a little pause, so what I need to do here is I need to label this because I'm trying to maximize the volume, So I need a volume function. So the volume is going to be what? The width times the length times the height. Everyone happy with that? I'll change that to the same looking L's. You guys happy with that? Okay. But what does it tell you about the width and the length? They're the same because it's a square based. Everyone happy with that? So if I just call that X, I'm going to call that X as well. The volume is going to be X times this H. Okay? Everyone happy with that? But we can't differentiate that, can we, just yet? We need a function with only one variable, to do this. So here's my canvas that I've stretched out. This is X, isn't it? Isn't that one there is X? Is that right? This one here is X. What are these two? H. Aren't they? Does that make sense?
Why do we have to have the delta and beta when they're the same?
They're not the same. We don't know that they're the same is the key.
All the sides are the same size.
We don't know that they're a cube. We don't know that yet. We're trying to prove it. It's cuboid, it says. Cuboid, that's a rectangular prism, not a square prism. So now, to get our area, which is 1,000, we need to say it's X times X plus 2H, don't we? Happy with that? Yeah? So we've now got a function where 1,000 equals x squared plus 2xh. Yep. What we're going to try and do now is to rearrange this formula so that it has h equals. Then we're going to substitute that answer into here and only have x's that we can differentiate, make it equal 0, and solve. Okay, I'll leave that with you just for a little bit. Okay, so as I just said, to rearrange that, you take away the x squared, and then you divide by the 2x, and you're left with 1,000 minus x squared all over 2x. Now you can simplify that a little bit. Okay, it is hard, I'm not saying it's not, but we are doing level 3 calculus here, so that's going to be 500 over x minus x over 2. Okay. There's our h. Substitute it into this h over here, because there is your volume function that we are trying to maximize. Okay? Okay, so I've figured out my h. There's my h over here. Now hopefully that is right. Just double check it, looks right. Yep. So I'm going to substitute that h into this h over here. So I'm just, it's going to be x squared, because x times x is x squared. And this is times, in brackets, 500 over x minus x over 2. Everyone happy with that? Oh, close bracket. Everyone happy with that? Now I can expand this bracket. I'll expand underneath because I don't have enough room up top. 500 times x squared divided by x, that's just 500 times x. X squared times that is just... So there is my volume function. There is what I have to maximize. Does that make sense? How do I maximize that volume function? Differentiate it, make it equal 0, solve for x. I'll probably get 2x answers. One will be a minimum and one will be a maximum. Yeah? I just got to prove which is which. So, v dash 500 minus 3x squared over 2. Now, you know, a maximum implies that v dash equals 0. Okay, so 500 minus 3x squared over 2 equals 0. How am I going to solve that? It's actually an easy way to solve that without doing any sort of factorising or anything. I'm going to add that to the other side so that I've got positive, so it's got a positive 3x squared over 2 times by 2 divided by 3. Okay, now how do I find that answer? Take the square root. So square root that, square root that. So x therefore is just 1,000 over 3, is that right? Plus or minus, because there is my maximum volume and my minimum volume. Well, you can't have a negative x on this particular occasion, can you? Right. So x is therefore, what is the square root of 1,000 divided by 3? 18.257. Say again? 18.257. Something like that, or is it that? Alright, happy with that? So if that's my x when I'm talking about my maximum, I probably should prove that. Is that right? Yeah. Should I prove that? How am I going to prove that? Secondary differentiation. Yep. So if I go back here, here is my v dash. So if I go down and say, what is v dash dash going to be? Negative 3x. Times by 2 divided by 2 cancels out. Happy with that? Okay, so when x is 18.257, what does v dash dash equal? It's a negative number. It doesn't actually matter what it equals. The value is not important. What is important is that it is less than 0. Because if the graph is less than 0, what does it tell us about our graph? It is concave down. And therefore, if it's concave down, it will be a maximum. Does that make sense? So this is our x. We've proved it's a maximum.
Do you need to
We just need to find the volume.
Do you need to prove it if you clearly can't have a negative x?
Well, it's this. I would. Looking forward to future exam questions. It might not be that it's because you can't have a negative that you wouldn't do it. Does that make sense? I would do it just for good practice. Okay, because that's what might happen in the exam. So how do I find my answer? I just chuck V back into, chuck 18.257 into that formula there. Happy with that? Let's finish.